Hello everyone and welcome back to Mathematics with Usman. This is my sixth and the last video in my series on the topic transformation. And this video is a special video since in this particular tutorial we are going to apply all the concepts that we have learned in the previous 5 videos together on the new situation problems. So the topic for today is transformation using different questions. Let us straight away move into the question number 1. In question number 1, students, you are given with the triangles A, B and C. In part A of the question, you are given that triangle A is mapped onto the triangle A by the transformation called translation. What you have to do is find the column vector for this transformation. To find the translation vector, dear students, just consider any vertex of the triangle A. Now move on to B and see the corresponding point of this vertex on the triangle B. And here it is. Now see, students, how many units this vertex of the triangle A will move in x direction and how many units in the y direction. 1, 2 and 3. It is moving 3 units in x direction and 1 unit in the y direction. So the column vector for this translation will be 3 units in x direction and 1 unit in the y direction. So here is the translation vector. If you want to consider any other vertex of triangle A, you can. Just for instance, take this vertex. It is moving 1, 2, 3. Positive 3 units in x direction and 1 positive 1 unit in the y direction. Hence, all the points of A will be translated with the translation vector of 3 units in x direction and 1 unit in the y direction, and you will get the image of A, which is B. Let us now move to the part B. What it says: find the matrix representing the transformation that maps A onto the triangle C. Now consider the triangle A in the given figure. And if you see its image, now it is mapped onto the triangle C. Students, if you carefully examine it, you can see that this vertex of the triangle A is mapped onto this. And you see there is no change in the y component of this vertex on both sides. However, the x component of it 2 becomes the negative 2, which means that triangle A is mapped onto C by reflection in the y-axis. And whenever object A is reflected onto C in the y-axis, you can check my previous tutorial in which I have given you the matrix for it. And the matrix for this particular reflection will be -1 because x is going to change, it's become negative. However, the y component is not changing, so -1, 0, 0 and 1. In part 3, students, what you have to do is triangle A is mapped onto the triangle D by an enlargement whose scale factor is 2 and the center is 5, 0. So let us first identify the center of this enlargement on the given Cartesian plane. It is moving x units in x direction and 0 unit in the y direction. So this should be your center. What we have to do is we have to draw and label the triangle D using this enlargement. So students, now consider any vertex of the triangle A. Let us consider this vertex first. Join it to the center. In enlargement, you know that the scale factor is equals to the distance of the image from the center divided by the distance of the object from the center, represented by the equation K equals to Ci divided by Co. And students, since scale factor is 2 and the distance of the point, means this vertex from the center is 1, 2, -2 in x direction and 1 in the positive y direction. So this CO will be multiplied with the scale factor 2, means 2 times -2 in x direction and 1 in the positive y direction. If you multiply them, what we are going to get 2 into minus 2, 1, we will get minus 4 in x direction and 2 in the y direction. Now move from the center, means the distance of the image from the center is minus 4, 1, 2, 3, 4 and 1, 2. Here we are going to have the image of this vertex of A. Let's draw it over here. Now consider the second vertex of the triangle A. It is again 1, 2, 3, negative 3 in x direction and 1 in the positive y direction. So if you multiply it with the scale factor of 2, what we are going to get? Minus 6, 2. The distance of this image will be negative 6 in x direction from the center and 2 in the positive y direction from the center. So start counting from the center. 1, 2, 3, 4, 5, 6, 1 and 2. So this should be the image of the second vertex of the triangle A. Now we are left with the third one and see the distance. 1, 2, negative 2 in x direction, 1, 2, 3, positive 3 in the y direction. If it is multiplied with the scale factor of 2, we are going to get minus 4, minus 6. 1, 2, 3, 4. Negative 4 in x direction, 1, 2, 3, 4, 5 and 6 in the y direction. So this is the image of the third vertex of the triangle A. Now if we connect them together, we will be able to find the image of A represented by the triangle D. To better understand the transformation, let us solve one more problem related to the transformation. Students, just consider this Cartesian plane. You are given with the shape A, B and C. They are drawn on the grid. In part A, students, what you have to do is, shape A is mapped onto shape B by reflection. You have to write down the equation of the line of reflection. Just students, consider any point of the figure A. Let us consider this point. If we see, the corresponding point of it is this vertex of the shape figure B. Now the distance between them is 1, 2, 3, 4. If we divide them equally, since it is a reflection, we will get the line of reflection. Because this is reflection, so the distance of the image and the object from the line of reflection will remain the same. So if the line of reflection is a line parallel to x-axis with the y-intercept of minus 1, that will give us the image and the object at the same distance. So line of reflection will be the straight line and the equation of it will be equals to y is equals to minus 1. In part B, students, you have to describe fully the single transformation that maps the shape A onto the shape C. And you can see it clearly. A is not preserving its shape and size, and the only transformation that does not preserve its shape and size is enlargement in our course. Now we know that the transformation is enlargement, but we have to give the center of enlargement and the scale factor. For that, students, consider any 2 points, one on the image and one on the figure, that are corresponding to one another. Let us consider this point, this vertex of A, and the corresponding point of it on C will be this point. Join them with a straight line like this. Now consider any 2 other points that are corresponding on the figure and on the image. Let us consider this point of the object and corresponding point to it on the image is this point. Join them with a straight line. You can see that, students, these 2 corresponding lines intersect at some point. Draw your point over there. That will be the center of enlargement. And if you see the coordinates of it, they are minus 3 for x and 2 for the y. So we have got the center now. The second important thing to find out is the scale factor. And to find out the scale factor, just consider 2 corresponding points, one on the figure and one on the image. Let us consider this point on the figure and its corresponding point on the image, and see the distance of this point from the center, and you can see it is 1, 2, -2, and its corresponding point from the center is 1, 2, 3, 4, 5 and 6 unit in the positive x direction. So students, your scale factor will be equals to distance of the image from the center, which is 6, divided by the distance of the object from the center, which is -2. Divide them and you will get the scale factor equals to -3. So students, how you are going to describe this single transformation? It will say that it is an enlargement with the scale factor of -3 and center -3, 2. Let us consider now the last part. Transformation T is represented by the matrix -1, 0, 0, -1. T maps shape A, means this figure, onto the shape D. Draw and label shape D. Students, simply remember, when you are given with the transformation vector, which is 2 cross 2 matrix, pre-multiply this matrix with all the vertices of the given figure. So what we are going to do, we will simply multiply -1, 0, 0, 1 with all the vertices of A. This vertex is -5, 1, this vertex is -6, 1, and this vertex is -6, 3, and the last one is -5, 2. So you can see that I have written all the vertices of the figure A in the column vector form. Now this is a 2 cross 2 matrix multiplied with the 2 cross 4 matrix. So number of columns in the second are equals to number of rows in the first. So they are comfortable for multiplication. At this point, I assume that you people are well aware of the matrices multiplication. If not, you can check it on my another tutorial. Here, the first matrix is 2 cross 2, the second is 2 cross 4. The number of columns of the second are equal to the number of rows of the first, and hence two matrices are comfortable for multiplication. And if we multiply them, we will get the first coordinate 5 minus 1, the second coordinate of D 6 minus 1, the third 6 minus 3, and the fourth 5 minus 2. Now if we draw them on the Cartesian plane, we will get the figure represented by D, which is the image of A, which is transformed by the matrix -1, 0, -1. And dear students, this brings us to the end of today's tutorial. I hope it has some value to your transformational concepts. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial. Till then, it's goodbye.